Hi everyone, so as promised, I said I'd make videos regarding the percentage yields questions from your mock paper this year. Because I wasn't sure which one you wanted me to cover, I thought it would be best to cover both. So I'm going to look at question 10 part A and question 11 part A. So if we have a look at question 10 part A, you can see they're sneaking an awful lot into the answer of this question. So I'm going to start by looking at part what we need to know from the question. So as I'm reading through it, I would probably go along with my highlighter and I'd underline the various things that we've used. So we've used some amount of manganese dioxide. They give you the formula for that. They give you how much of the acid you use, and they give the concentration of the acid you use. And remember, the how much is going to be really important. The next thing I need to notice are my numbers in front of everything in the equation. So there's none in front of my manganese dioxide, there's a 4 in front of my hydrochloric acid, none in front of my manganese chloride, none in front of my chlorine gas, and then 2 in front of my water. So as always with limiting reagents, we have to convert everything to moles. When you're talking about limiting reagents, you have to look at your reactants. So our reactants in this case are manganese dioxide and our hydrochloric acid. So in my question, it tells me I have, of my MnO2, I have 5.3 grams. Now that 5.3 is no good to me. What I want to do is I want to convert that to moles, and we know the easiest way to do that is to divide by my relative molecular mass. So let's just carry that calculation out. So the relative molecular mass of manganese is 57 and I only have 1. Oxygen, we should all know by now, is 16, but with oxygen I have 2, tells me in the formula, so that's 32. So I add both of those figures together, and when I do that I get 87. So to complete this calculation then, I take my 5.3 grams, I divide it by my 87, and I get an answer of 0.06 moles. Now we need to compare this with our other reactant, which is hydrochloric acid, HCl. So again, I can see in the question that it tells me I have 150 centimeters cubed of a 1 molar acid. So I need to figure out how many moles of this I actually used. So to figure that out, I take my 1, I divide it by 1,000, because remember, capital M is equal to moles per litre. And I multiply it by what I want, and in this instance I wanted in 150, and I get an answer of 0.15. So these two figures are going to be really important for us moving forward now. 0.06 and 0.15. What we need to look at now is we need to look at the ratio between these two. So I'll go back to my equation and I can see that there's nothing in front of my MnO2, and we know that that represents 1. I can see there's a 4 in front of the HCl, and we know that that represents 4. I know from what I've worked out that MnO2 represents 0.06. So that's what 1 represents. I know we've used 0.15 moles of my HCl. Now, in order for this to work, I need 4 times the amount of my MnO2 if this ratio is to work. So I multiply my 0.06 and I realize that if I was to use every single of my 0.06 moles of MnO2, I would require 0.24 moles of HCl. However, we've already calculated we only have 0.15 moles of my HCl available. So in this instance, my HCl is the limiting reagent. The next part of the question is asking me what mass of manganese chloride was formed. So this time around we're jumping to the product side of my equation, and there's my manganese chloride. So I want to figure out the mass. Remember, mass is equal to grams. And I can only use what I know already, and the only things I know already are my manganese oxide and my hydrochloric acid. I know that I have 0.06 moles of my manganese dioxide, and that if that is to work properly, I have 0.24 moles of my HCl. Now, I know that we actually only use 0.15 moles of my HCl, and we figured out in the previous question that that was my limiting reagent. So we use that to help us calculate the ratio across the board. If we have a look at the ratio between hydrochloric acid and my manganese chloride, I can see that it's 4:1. So I've used 4 times the amount of hydrochloric acid as I will manganese chloride. So to figure out my grams of manganese chloride, I'm going to divide my 0.15 by 4, and I get 0.0375. Remember, that's in moles, and I want my answer in grams. The easiest way to do this is to multiply by my relative molecular mass. Again, we don't want to lose any marks, so we're going to take our time now, and we're going to calculate the relative molecular mass of manganese chloride. So Mn is equal to 255. Chlorine is one of our ones that we keep our decimal point. It's 35.5, but I have 2 of them. So that brings me to 71. I add my 71 and my 55 together, and I get a total value of 126. So finally, to figure out my number of grams, I take my 0.0375 and I multiply that by my relative molecular mass, which is 126, and we calculate that we would theoretically produce 4.725 grams of my manganese dioxide. The third part of this question is asking you to calculate the volume in centimetres cubed of chlorine gas measured at STP that's produced. Now, we all know that this comes back to ratios. So if I look at the ratio between my manganese chloride and my chlorine gas, I can see that it's 1:1. I know that we produced 0.0375 of my manganese chloride, so I must produce the same amount of chlorine gas. We also know that at STP, 1 mole is equal to 22.4 litres, or that's equal to 22,400 centimetres cubed. Remember, if you flick back up to the question, they want the answer in centimetres cubed. So we take our 0.035, we times that by our 22,400, and when we do that, guys, we get an answer of 840 centimetres cubed. The final part of this question is a theory part. So like I said, the final part of this question is a theory part. So to test for the chloride ions, these are your anions tests that we would have done in 5th year. You're talking about adding silver nitrate. Now we need to know the formula for silver nitrate. Our formula for silver nitrate is AgNO3. And when you add silver nitrate, if chloride ions are present, we get a white precipitate formed. And that's the end of that question, guys. Okay, folks, so now we're going to have a look at question 11 from section B and part A. So this time around it's broken up into 2 parts, which was present in excess and then our percentage yield. So again, when I'm starting these questions, I would always look to see what I can know from the question. I see that I use 7.45 grams of sodium dichromate and that there is 4.14 grams of my ethanol. The ethanol then was removed and the yield of ethanol is found to be 1.98. So for the beginning, I'm looking for 2 reagents and which one to see was present in excess. Now remember, in excess means I have more than I necessarily need. And from the previous calculation, we can only work with this when we come to moles. So I'm going to start off with sodium dichromate. Na2Cr2O7 2H2O. Now I can see that there's 7.45 grams of that, and like I said to you, grams is no good to me. I need to convert that to moles, and we do that by dividing by my relative molecular mass. The easiest way to do that is to do it all out. So I have sodium, and I have 2 of those, and sodium is 23, so in total that's 46. Next thing we're going to do is chromium. So chromium is 52, and again I have 2, so that gives me 104. My next one that I have is oxygen, and oxygen is 16. I have 7 of them in this instance, and that leaves me with 112. Now, when it comes to water, if we have a look at it here, we can see that it's 2H2O. Now, if we deal with H2O individually, hydrogen is 1, and I have 2 of them, so that's equal to 2. Oxygen is 16, so 16 plus 2 to give me 18 in total. But I have 2 water molecules, so in total that H2O is contributing 36. So I have to add my 2H2O onto this now. And when I add all those up together, I get 298. Okay, so to convert my sodium dichromate to moles then, I take my 7.45 grams and I'm dividing that by the relative molecular mass, which is 298, and that leaves me with 0.025 moles. Hopefully the ethanol will be a little bit easier to calculate. So we take our ethanol and we have to do the exact same thing with our ethanol. From the question I can see that we have 4.14 grams of it, and we know to go from grams to moles I need to divide by my relative molecular mass. So my chemical formula for ethanol is C2 H5 OH. So like we did the last time, we're just going to calculate everything out. So carbon is 12 and we have 2, so that's 24. Hydrogen is equal to 1, but be careful, I have 6. So that's equal to 6, and then oxygen is equal to 16. I only have 1, so that's 16. And when you add all of those up, guys, we should get 46. So we take our 4.14, we divide that by 46, and we're left with 0.09. Right, guys. Going back to my balanced equation, I can see that we use 3 times the amount of ethanol as we do our sodium dichromate. So we get a 3:1 ratio. Now, we can also see that if I have 3 moles of 3 times the amount, so for example, we figured out that we had 0.09 moles of ethanol. If I have a look, I can see that that would require 0.03 moles of sodium dichromate. We figured out that we have 0.025 moles of sodium dichromate. So we have way more ethanol than we need. In fact, for this 0.09 to be used, you would need 0.03 of my sodium dichromate, and we actually only have 0.025. So that tells me that my ethanol is in excess. I have more of it than I need. My sodium dichromate is my limiting reagent. Why? Because if this was to react perfectly, our ratio would be 3:1. I would have 3 times the amount of ethanol than I would sodium dichromate. I actually only have 0.025 moles of my sodium dichromate, which is 0.005 short of what I would need, and that's why it becomes our limiting reagent. So guys, the final part of this question is asking you to calculate the percentage yield of your product, which is your ethanol over here. Now to do this, we need to look at ratios across the board. We know our ratio between the 2 main product reactants involved was 3:1, and I can see that the ratio of my product is 3 also. Now when you're working with things like this, you always have to be really careful. You work with the limiting reagent, and we figured out in the last question that our sodium dichromate was the limiting reagent. In fact, the 1 represents 0.025, and I can see from the question that I'm going to make 3 times the amount of ethanol. So to calculate that, I take my 0.025, I times that by 3, and I get 0.075. To calculate my percentage yield then, so that's my theoretical yield. I take my theoretical yield and I want this in grams, because if we read back through the question, you can see they gave us the actual yield in grams, so we need to convert everything to grams. I'm going to need to multiply my moles by my relative molecular mass. So for ethanol, ethanol has 2 carbons, and we know carbon is equal to 12, so that's 24. It has 4 hydrogens, so that's equal to 4, and we can see that it has 1 oxygen, which is equal to 16. And when you add all of that up, guys, we end up getting 44. So we take our 0.075 and we times that by 44, and when we do that, we get 3.3 grams. So to finish off the calculation, we take the actual yield, which we're given in the question, as 1.98 grams, and we divide that by what we've just calculated, our theoretical yield, which is 3.3 grams. We multiply that by 100 over 1, and we get 60%. Remember, when you're calculating percentage yield, it's always really important that both of your units are the same. So, for example, our question here was both in grams. Why? Because it gave us the actual yield in grams in the question.